All right, let's continue with what we were doing yesterday. Let's just review briefly since we've had a whole 23 hours since we've done this stuff. 23 and a half hours, whatever it's been. Okay, let's review just briefly. Let me take a look at my notes here. There's a couple things that were pretty important that we're going to use in this. We're only doing 2 examples today, all right? But they're a little bit tricky because you've never done anything like this before. You really haven't. This is kind of like the first time you've done this stuff. So it's always going to be a little tricky the first time you do something. All right, so this is important. These little squiggles right there are supposed to be squareds. They look pretty bad, but there you go. Right? So that's super important. So know that. All right, so the sine squared plus cosine squared is 1. But then remember what we did yesterday? You can look in your notes if you want to. We got sine squared by itself. If I wanted to get that by itself, what do I have to get rid of? The cosine squared. Okay, how do I get rid of the cosine squared? It's being added, so we subtract it. That's right. So what's this? Oops, come on, pen. What's the sine squared going to equal then? It's going to be, no, we take this, we put it to the other side. So it's going to be 1. It's not 1 cosine. We're subtracting.
1 minus cosine.
That's right. We're subtracting it from both sides. So we subtract. Right? You subtracted this, so you subtract it from here, right? Look, you shouldn't have to show this. Okay, we should know this by now. If I subtract it from here, you know it's going to cancel out and go away, right? If I subtract it from here, what do I got to do over here? I got to subtract it from over here. Okay, and that's how we get 1 minus cosine squared. Why doesn't what?
The one on this other side cross out as well.
Why would it? This right here, this 1?
Oh, okay.
You saying that 1 or this?
That cosine.
Because I just subtracted it. There's nothing to cancel out with it. Right? Look, I subtracted it from here, so they cancel out. 1 cosine squared minus 1 cosine squared is what? 0. So it cancels out. So I subtract it from this side. Look, it's as simple as this. X plus 1 equals 3. This is what it goes. You guys are making this way too confusing in your head, all right, because the cosine squared. Think of it as just a number, all right? What is this 1? That's a number. How do I get rid of that number? I subtract it. What do I do to the other side? I subtract it. That cancels. X equals 3 minus 1. All right? It's the same exact thing, except instead of this being x, it's a sine squared. Instead of this being a 1, right, it's a cosine squared. But the math is the same. The algebra is the same. Everybody see that? Okay. So that's that. What if I wanted to, tell you what, let's get rid of a bunch of junk here. Let's get rid of this. Oops, don't want to get rid of that. All right. What if, let's get rid of this circle and this. All right, what if I wanted to get the cosine squared by itself? Then what would I do? No, come on. Let's think. Think. If you want to get this by itself, you have to get rid of the stuff that's with it. What is next to? What's with the cosine squared on the same side? The sine squared is. So that's what we want to get rid of. If I want to get cosine squared by itself, all right, let's come over here and do this. You're making this way harder than it is. It's really actually kind of simple once you get it. All right, so watch. What if I want to get cosine squared by itself? For instance, if this was like 3 plus x equals 5, okay? And I'm going to get x by itself. What would I do in this situation? I would subtract a 3 from both sides, okay? Are you watching? Okay, so if I want to get cosine squared by itself, what do I get rid of? The sine squared. How do I get rid of it? I subtract it. Look, divide? Is that what you said? Okay, I thought you said divide. I think you did. So look, follow the pattern. There's a pattern here. This is the reason I showed you this. Okay, this is very similar to this, except the 3 is a sine squared. The x is a cosine squared, and the 5 is a 1. Okay, I'm just showing you how the algebra works. So if I want to get x by itself, What's the thing that I want to get rid of? Come on, talk to me. What do I, forget this. This right here, we're staying right here, okay? So don't say cosine, don't say sine. I'm just looking at this thing right here. Sorry I'm getting a little frustrated, but this, maybe I'm just not explaining it correctly. Or maybe you're just not thinking, I don't know. If I want to get x by itself, what do I get rid of to get x by itself? The 3, not the 5. Come on, this is pre-algebra stuff, okay? If I want to get x by itself, look, what's on the same side of the equal sign as the x?
Oh, I get it. So
It's the 3, okay? Everybody see that? All right, so what do I want to get rid of? I want to get rid of the 3. How do I get rid of the 3? This is being added to this, so I subtract it. Same situation. It's a little more complicated. It's not exactly the same, but it's very, very similar, okay? The algebra is the same. So if I want to get the cosine squared by itself, what do I want to get rid of that's on the same side of the equal sign? The sine squared. How do I get rid of the sine squared, that whole thing? This is being added to this, so I subtract it from both sides. So I've got cosine squared equals what? 1 minus the sine squared. All right? I really didn't think that was going to be that much trouble, but that's okay. I'm glad we went through it. So there you go. So those are important things to remember for what we're going to do next. All right? All right, I thought that would go a lot faster, but it didn't. That's fine. Let's do a couple more. Well, 4 more. Keep that there. All this, I'm going to put a bunch of stuff in boxes. That's the stuff that's important for us to keep in the back of our mind, and we're going to use those facts to do what we're going to do today. Okay? We're not going to go through why this is what it is, because we did that yesterday. But do you remember that the tangent of x is equal to what? The sine over the cosine of x. We went through an explanation yesterday. I'm just not going to do that today. All right? So that's something you should know. Everybody understand that? Sine over cosine, y over x, opposite over adjacent. Okay? That's what that is. The sine would be opposite the tangent. The cosine would be adjacent to the tangent. All right. Or that angle. Not the tangent, but the angle. All right. Let's do another one. This is a brand new one that we learned yesterday. We learned what the secant was, didn't we? The secant of an angle. Let's use x since we've been using x all along. So what's the secant? It's the inverse of the what? The cosine. Now, how do we know that the secant and the cosine are the ones that go together? It's because they're inverses of each other. And look, that secant has an s, starts with an s. The cosine starts with a what? With a c. That means they're opposite each other. A lot of people will think, oh, the secant and the sine are inverses of each other. But they're not, because they both start with the same letters, start with s. So they don't go together. Remember, these are inverses of each other. So you have to think, okay, secant. Oh, it's the one that starts with the other letter. All right, and what's the other letter? Not s, but c, cosine. Does that make sense? So that's important. Put that in a box. And what was the other one? Cosecant? How do we abbreviate cosecant? CSC. All right, we use CSC. It's the only one where we don't use the first 3 letters. Because if you did cosecant, it would be COS, and then we'd be confused between cosine and cosecant. All right, so we write it like that. Huh? Because it's cotangent. Because cotangent, then you'd have 2 things that were the same. All right, so we write CSC. They always do. Everybody does. All right, we want to be one of the cool kids. We'll do what everybody else does, okay? So CSC. This is the cosecant. The cosecant is the inverse of what? Remember, this starts with C, so it's the inverse of the one that starts with the other letter. So it's 1 over what? No, the other letter. It's cosine, sine, C and S. Those are our 2 letters. 1 over the what? 1 over the sine. Okay? So that's the cosecant. Now, the next one is super easy because they both have the same word in it, all right? And that would be the cotangent. You could put theta, you could put A, you could put B. No, I just decided to use X. You got to take the cotangent of an angle. These things right here represent angles. Every one of these. Shh. Smart. Doesn't help. Okay, all these are angles. You can only take the secant, the sine, the cosine, the cosecant, the cotangent, the tangent of an angle, right? Everything's of an angle. What does this mean? What does the sine mean? It means, okay, I'm going to take that angle, then I'm going to look to see the opposite side, and I'm going to divide it by the hypotenuse. That's what the sine means. What does the cosine mean? It means I'm going to take that angle x, wherever that is, and then I'm going to look at that angle, I'm going to look at the adjacent side, look at the hypotenuse, and divide them. Put adjacent over the hypotenuse. That's what these words mean. It's not a variable, all right? You can't divide by them. You can't multiply by just a tangent. Now, right here, this is a number if I knew that angle. Okay, if I knew that angle, okay, I can put it into a calculator, take the sine of it, then square it, and I get a number. All right? So this right here represents a number. The secant of x represents a number. But just the word secant itself, or the word cosine itself, or sine itself, is just tells you a ratio between one side and another side. That's what it's telling you. All right, let's continue with this. The cotangent of x would be 1 over the what? This is an easy one because they both have the same word in it. What is it? 1 over the, look, this is cotangent. So it's 1 over the tangent. Guys are slow today. Come on, keep up with me, all right? It's not that hard. I'm making this easy for you. I'm like setting the table. All you got to do is sit down and eat, all right? I'm setting the table. So this is what? 1 over the tangent of x. Okay? So those are all important. I thought that would take like 2 minutes to go through all those. All right. Well, I haven't even done anything yet. All I'm trying to do is get you to remember these things. That's all I'm trying to do right now. Okay? Don't worry about how we're going to use them, where they're going to go. We're going to do it in just about 10 seconds. Okay? All right. So those are key things to remember. All right. I'll tell you what, I'm going to redo example 3 just to kind of get us thinking again, all right? We did it at the end of class yesterday. I will redo it. Example 3. So what we're going to do is we're going to prove all these. We're going to do 3 examples today, 3, 4, and 5. And we are going to prove what they give us, all right? So we want to prove that the sine of x times the secant of x is equal to the tangent of x. If you remember yesterday, we take the side that looks the most complicated and we try to take that, simplify it, and try to make it look like the other side. Doesn't matter if it's the left side or right side. Okay, this could have been tangent x equals sine x secant x. So which one looks a little more complicated? Yes. This one right here. Yes. Yeah, just like x, y equals something, right? They're being multiplied. So these are being multiplied times each other. Yes. Good question.
Instead of doing, so we're going to go from 10.
No, we're going to go from this. We're going to go from the more complicated one and try to make it look like the one that's a little simpler. So we're not, no. Well, yes, but you're not going to. All right? You're not going to. You're going to go from here to here. Everybody see it? So you go from the one that looks more complicated and you try to make it, you try to break it down into stuff that you know. Break it down until it looks like this. Does it make sense? You guys watching? Okay, so sine of x. Can I break down the sine of x into anything? It's not sine squared of x, is it? If it was sine squared of x, it's not, but what if it was? Then I might break it down into this, right? Or if it was 1 minus cosine of x, you could look at it and say, oh, I know what that is. That's the sine squared of x. All right. So we can't really break down sine and cosine. That's broken down as far as you can. Tangent, we could break down tangent. Now, we're not going to on this one because it's the simpler side, okay? But what is, just listen, what is the tangent? Tangent is what over what? Just wrote it down. It's the sine over the cosine. Okay, but I'm not going to do that. I'm going to take the one that looks more complicated, which is this one, because there's two things over there. There's only one thing here, right? We're going to take this, we're going to break it down, and hopefully we're going to make it look like this. Probably. I would probably say that, yeah. But when you look at them, you'll know.
Can you do another problem after this one?
I got two more.
If the other side is the one that happens to be the more complicated one?
You'll see. It's the stuff with the most, it's the side with the most stuff. All right, we'll just say it that way. Not the most elegant mathematical explanation of it, but it's kind of what it is. All right, so you just take the side that's got the most stuff and you try to make it look like the other side. Now, you could start with the other side, the tangent, and make it look like this, but it takes a lot more thought. All right, it's way too complicated to do that. So we're going to take the complicated one and make it look like the one that's just a little bit simpler. Let's just do it. No more questions, okay? Let's just do it and you'll see. Then you can ask some questions after we're done doing this, okay? So the sine of x, it's already broken down. We can't really do anything with that. But the secant of x, we do know what the secant of x is equal to, don't we? No? Look, secant of x is equal to what? Look at it. What is it equal to? I'm sorry. I'm trying to contain myself. But it says secant of x equals, and you're telling me tangent. No, what is it? It's 1 over the cosine of x. All right? Oh, my word. Okay. So this is times, right? You said, right, that it was times. What is the secant? 1 over the what? Cosine of x. Since it's multiplied by a fraction, let's just put that over 1 just to make it look like you got two fractions. I'm not touching this thing on the right, all right? I'm just going to work this side out. I'm not going to work both sides. I'm not going to take one side, then another side, and simplify them both. I just take one side, I simplify it, and I try to make it look like the other side. You with me? And once I do that, that's my proof. Now, let's take a look at this. Let's multiply. What's this? Well, sine of x times 1 is just what? Sine of x. What's 1 times cosine of x? It's cosine of x. Now, let's come back up here.
Is there anything else you can put but 1, or does it have to be 1?
What do you mean? What do you mean?
Like, see how it's sine x over 1?
Yeah.
Could it be like sine x over 2?
Well, then it wouldn't be the sine of x. Sine of x over 2 is not the same thing as the sine of x, right? But sine of x over 1 is the same thing as sine of x. So no, you cannot put this over 2, all right? All I'm doing is rewriting this. Why did I put it over 1? What was the purpose of that? Because well, it's not to match the other side. It kind of, I guess. It's because you're multiplying fractions together, right? So you want a numerator and a denominator. So I decided, well, this could use a denominator. And what would the denominator be? It's just a 1, right? It didn't change the value of it at all. Go ahead.
Could x come in the form of a fraction?
X is a angle. Sure, it could be a decimal. It could be 36.7218 or whatever. It could be anything. Okay, but we don't care about the angle. All we're trying to do is show that this side is equal to this side. Let's keep going. So now, why did I bring it up here? Because, look, sine x over cosine x. Do you recognize that in these boxes?
Yes.
Yeah, what is sine x over cosine of x? It's the tangent. That's right. So, guess what we just did? We did it. So, the sine of x over the cosine of x is just the tangent of x. Check it out. We just simplified this to make it look like the other side, didn't we?
And then tan equals tan. And then
Yeah, you're done. You don't even have to say tangent of x equals tangent of x. All you had to do was this. It shows that this is equal, and you're good to go. There's your proof. You are done. Okay, and you say, well, what's the answer? Well, the answer is the whole process. The answer is not just x equals 3, x equals 5. That's not the answer. The answer is this whole entire process. Each one of these steps, That's our first step. Here's our second step. Here's our third step. That is the proof. That's the answer, if you want to call it an answer. It's not really an answer. We're just showing you how we got from this to this.
Will this be on the quiz?
Oh, absolutely. If I'm teaching it, and if it's an example, absolutely it could be on a quiz.
Will it always be 3 steps?
No. All depends on what they want you to prove. Let's do another one.
Wait, I have a question.
Go ahead.
So you know how when we were doing the 30, 60, 90,
Yeah.
it was like 3 squared 2 over 2. Well, could that be an x and then we have to switch?
No, because when you have the square root of 3, what'd you say, square root of 3 over 2?
Yeah.
That's never an x. That's like the cosine of an angle is equal to the square root of 3 over 2. All right? So the x is an angle. But we're not solving for x here. We're not trying to find what the angle is.
So x just stays as
Yeah, exactly. Okay? They could have made that a theta. They could make it an A, a capital A. They could make it a capital Z. Could make it a capital Q.
Oh, so there's never going to be a number there?
Not with these type of problems. We're not really, it's just to show that this is equal to this.
So we're not solving for anything.
That's correct. We're not really solving for anything. That's what I've been saying. We're just showing the steps on why, okay? Here's the thing. Why, okay, is this equal to this? This is why. Okay? That's all we're doing.
Is this the only proof we're going to be doing?
No. This is the one we did yesterday.
Oh.
We haven't even started today's lesson yet.
Okay.
Okay? But thanks for following along yesterday. All right. Should have looked familiar. I'm glad we did that one then. I was going to skip it. All right. Let's do, oh, what's going on there? There we go. All right, here's another one. Here's another proof. This is 1 plus cosine x times 1 minus cosine x equals the sine squared of x. I don't think it's that difficult to figure out which one's the more complicated side. Do you?
No.
Which one's more complicated? Left or right?
Left.
The left side. Okay, look at all this stuff. Remember, the side with the most stuff is the most complicated one, right? That's got way more stuff than that's got. Would you agree? So what we want to do, we want to go through a series of steps. Okay, we want to do stuff to this to make it look like that. All right? Now, let's think ahead a little bit. We're trying to make it look like sine squared of x, correct? Do we know something about sine squared of x?
It's equal to 1 minus that
1 minus what?
one. Right?
Cosine squared of x. See, sine squared of x is equal to what? 1 minus the cosine squared of x. So, a hint, right, might be, maybe we can get this thing to look like what? 1 minus the cosine squared of x. All right, that's probably a good guess of what we're trying to do here. Wouldn't you think? All right, so what can we do with this? I got 2 parentheses, so what does that mean these two things are doing?
Combining.
Not just combining, say it. They're multiplying together, all right? Now watch. Listen, watch this. We haven't done, this is geometry class, okay? We haven't done a whole lot of this in geometry. I don't know if we've done this at all, but this is something that you should have known from Algebra 1. If you didn't, I'm going to show you right now. Do you remember, I'll just use A and B. What if I use A plus B times A minus B?
Oh, is this one the distributive property?
It is. It's,
Oh my
it's
gosh.
exactly distributive property. Over under? It's not over under.
Isn't it the foil?
It is the FOIL method.
Oh,
Okay?
Look at me.
All right, shh. All right. I'm glad you're excited, but let's stay professional. Let's stay calm. All right, let's watch how to do this. Stay professional. Well, get professional. Shouldn't say stay because she's a long way. She's a long way from there. All right. But I appreciate the enthusiasm, though. I do. So watch. FOIL method says you multiply the first, the outside, the inside, and the last. Do you remember that from algebra? Yeah. All right, so let's do that with the a and b, and then we're going to do it with this stuff, okay? So let's do it. First, a times a, which is what? A squared. Let's do the outside. A times negative b, or negative what? AB. Did you agree? Right? The outside, this is the outside, that's the outside. Let's do the inside right here. Positive b, positive a, positive what? You could be a, but AB is a little bit better, so it looks like that. Everybody with me? And then positive times a negative is negative, and b times b is b squared. Now watch what happens here. It doesn't always happen with every FOIL method problem, but on this particular one, it does happen. Look at this. Negative AB plus AB, what happens? They add up to 0. So what's my answer? A squared minus b squared. This is a special type of factoring called the difference of two squares. Do you remember that in Algebra 1? Yeah. The difference of two squares? Because here's your difference. Is that rain? Oh, man. All right, so that's, listen, there's your difference, and there's two things that are being squared. Would you agree? Okay, I just circled the minus sign. Look at this. In the same kind of thing, there's your A, your 1 and your 1, and there's your B, your cosine and your cosine. And you got one as a plus and one as a minus. Now, let's keep going. All right, I'll never be able to finish if I stop every 2 seconds. So let's do the FOIL method. 1 times 1 is 1, right? Right, it's 1 squared, but what's 1 squared? It's 1. What happens with the outside and the inside now? They cancel out, all right? So we could do it if we wanted to. What's 1 times negative cosine? It's negative cosine. What's positive cosine times 1? It's a positive cosine of x. Okay, I'm just kind of shortening it a little bit. See how they cancel out now? But you should have looked at this and recognized that the outside and inside are going to cancel out, so you didn't even have to bother doing that. What's the next part? Positive times negative is negative. What's cosine times cosine? Cosine what? Squared. And that's how we write cosine squared. We do it like that. Yes? Yeah, I mean, just you got to do what it tells you to do, all right? It's showing you right now that this times this, so I'm like, okay, because I can't really break down cosine. I can't break down this cosine. I can't break down a 1. Really, what's the only option I have? The only option I have is to just multiply those together. Would you agree? It's really the only thing I can do with those. All right? So, I mean, I guess you could, like, divide by one of them, but then that'll be a mess. But I don't want to do something to one side and do it to the other side. I just want to do stuff to that one side, work it out, and hopefully we're going to get something that equals this. So I don't want to add something to one side, add it to the other side. You with me on that? Not with these proofs. I don't want to do that because I'm not solving for anything. I'm not trying to get x by itself. All right, so what happens here? They cancel out. Watch, look what we're going to get. We're going to get what? 1 minus cosine squared of x. What did I say at the beginning? What was the hint? Let's look for that, right? So what is 1 minus the cosine squared of x? It's the, not sin, what is it? It's the sine squared. So 1 minus the cosine squared is equal to the sine squared. So look, we are pretty much done now, aren't we? What's 1 minus cosine squared? It's the sine squared. And look at it. Look at this. That is the same as that. I'm done.
So essentially, we're just working out the problems until we get one of the boxes you circled up at the top.
Well, it's not the box that I circled. I mean, the stuff that I put in boxes were just hints for us that we can use to do this stuff. Okay? All right, let's do another one. I think you're starting to get the hang of this. All right, I'll write it. I'll write the problem down. All right, so here's the next one. We want to prove. This is the last one we do here.
Are these the only type of proofs that will be like on the quiz? Or
Yeah.
is it going to be a variety of different answers?
Anything that I do for examples, anything I do in front of you is possibility on a quiz or a test. Everybody good to go up now? All right. Which one looks a little more complicated?
Honestly?
No, doesn't. What's got more stuff? Come on.
It's just the one, so I thought it was something similar. Yeah. Like this.
What's got more stuff?
The left.
The left side, okay? Hate even saying that. Feel terrible as a math teacher saying what's got more stuff, right? But this left side's got more stuff. So I want to take this and make it look like that. Now, do I have anything in my boxes that has cotangent squared plus 1? Do I have any cotangent squareds in any of these boxes? Nope. But I do have the cotangent is equal to what?
Equals
1 over the tangent. So I do have that. I also, here's another thing. I didn't write this down, but we could. So watch. The tangent of x is the sine over the cosine. I didn't write this down, but we could say the cotangent of x would be what? If the tangent is the sine over the cosine, the cotangent is just the inverse, the reciprocal.
Cosine over.
Yes, it's the cosine over the sine. I didn't write that down, but we could, couldn't we? Let's put that in a box. Because look, the cotangent, listen, let's pay attention. The cotangent is 1 over the tangent. That means it's the reciprocal or the inverse of the tangent. Okay? What is the tangent? Sine over cosine. What's the reciprocal of that? Cosine over the sine. So cotangent is the cosine over the sine. Maybe we'll use that fact. All right? So let's, oops. Yeah, absolutely. Anything that's true, anything that is equal, you can do that. No, you're going to have to know these. You got to know these. That's not hard. Look, that's not hard. Look, sine squared plus cosine squared equals 1. That's Pythagorean theorem, isn't it? Yeah, a squared plus b squared equals c squared. Okay, and look, how did you get from there to there? You just subtracted a cosine. Easy. How'd you get cosine by itself? You subtracted a sine squared. Tangent, you got to know, but it's not hard to know. If you draw a right triangle, the tangent's the opposite over the adjacent. The opposite is the sine. The adjacent is the cosine. You should know that. These right here, these things you have to know. That the secant is the inverse or the reciprocal of the cosine. Remember, the s and the c, they're inverses of each other, right? The cosecant and the sine are inverse of each other. Cotangent and tangent are inverses of each other. That's super easy, isn't it? Cotangent and tangent. Yeah, they're inverses of each other, all right? Or you could, instead of writing it in terms of tangent, you could break it down into its sine and cosines. All right, let's go back to the problem. Watch this. So the cotangent squared. Now, you know what the cotangent is. I'll write this over here. Remember what the cotangent is? It's what over what? It's 1 over the tangent, but I want to break it down into sine and cosines, though. All right, and I just did that earlier. What is the cotangent? I just wrote it down. Did you write it down? Why didn't you write it down? I did. I put a box around it. What's the cotangent that I just wrote down? That's it. It's the cosine over the sine. That's why I did all that stuff, okay? Everybody see that? All right, so if the cotangent is the cosine over the sine, what do you think the cotangent squared is?
Cotangent squared is cosine
Squared over, not equals, over, it's not equal, what? Over the sine squared of x. It's sine squared of x. That's how you say it. Cosine squared of x. Sometimes I'll shorten it. Instead of saying of x, I'll just say cosine squared over the sine squared. But technically, yes, it is cosine squared of x. Because that's how we say it.
No, why are we doing it over sine square root of x instead of cosine?
Because the cotangent is the cosine over the sine. So the cotangent squared is going to be the cosine squared over the sine squared. Okay? Everybody with me? Got a couple. Knocked them out. Boom. I could be a good fighter. I can knock my opponent out just by teaching them math. Then they'd be on the ground in a second. Good strategy, yeah. Plus 1 equals I'm not even going to put the equals thing, okay? Again, we want this to look like this. Well, we're not there yet, are we? All right? What are we going to do? Plus 1. This is a fraction, isn't it? I'm not going to subtract anything because I'm not putting anything on the other side. Remember, this is a wall. Nothing can go up on the other side, okay? So, what could I do with this? What if I had, I'm just making up something, just completely different numbers, okay? What if I had 4/5 plus 1? What would you do? If I put that right in front of you, what would you do?
Combine it. 1, 4, 5.
Let's not put a 1 then, all right? Because it would be 1 4/5, that's true, but I want you to think of some other thing. I want you to put plus 2. Let's do that. What would you do? That's it. I'd put it over 1, and then I'd find a common denominator. Okay. Thank goodness you guys learned stuff in your math class. All right, so let's do this. So this is going to be over 5. This is going to be over 5, correct? So that's 4/5. This is going to be what? 1 times 5, right? 1 times 5. And then what? 2 times 5, which is 10. And then you can add them up. You with me? Let's come over here and do the same thing over here. It's a little more complicated, but it's the same idea. Same basic idea. So I'm going to put my 2 denominators. That's 1 denominator, right? Plus another denominator. What's on top here? All I'm doing is just rewriting this, just like I wrote 4/5 and I wrote 4/5, okay? So look, this and this are exactly the same, but I want to find a common denominator. So what's the denominator? Just the sine of x, or sine squared of x, okay? So I make this sine squared of x. What's the top going to have to be?
1.
No. 1 over the sine squared of x is not the same as 1. It has to be the same as 1.
No, you're wrong.
Yes. No, she's absolutely right. Look, what does that equal?
1.
It's 1. And that's what we had up here, isn't it? So this is a 1. So watch this. I'm going to go, I want to add them together. So what's this if I add those together? I make my 1 common denominator, and then I add them together, correct? And then I get whatever I get. Like these two? But then I'd be back with what I started with. No. No. You can't do that. Right? I can't go 5 goes into this and 5 goes into this twice. I can't do that. That breaks the rules of adding fractions. All right. Let's just do it, okay? You're making me take way too long. Look. So now, what do I have? I got a common denominator, don't I? So I write it as 1 common denominator, just like I did right here. So now, what do I do at the top? What did I do at the top to these two? I added them up, 4 plus 10. So how do I add those up? Well, look, I just went 4 plus 10. I didn't even get a 14 out of it. I just put 4 plus 10. So what do I do with the numerators here? Just cosine squared plus what? Well, it's not really an answer. We're not there yet. We're almost there. We got like 2 steps and we'll be done. That's why this is the last one, because it's a little more complicated than the other ones. See what I did? The only thing I did was just take this and add it to 1. I found a common denominator, sine squared, because that was my denominator here. I turned this into sine squared over sine squared, because that's a 1. Then I put it over a common denominator, right? So my common denominator, I just put it once, and what do I do with the numerators? I just add them up. Cosine squared plus sine squared. Okay? Now, do you recognize something? What do you recognize, Gabby? Go ahead. What's that? No. You can't cancel that stuff. It is. Well, look at it. Look at it. Open up your notes and look at them. You should see something.
Is it cosine squared x equals 1 minus
No.
sine?
It's before that.
Oh, is it sine squared x equals 1 minus cosine
No.
squared?
You should see something. Come on. Look at your notes. You guys are killing me today. Look at your notes. You should see something in your notes, in a box, that is this. that's cosine squared plus sine squared? Look in your notes. Say it. It's 1. It's equal to 1. Well, you've been asleep the whole time. I didn't even think about listening to you. So, all right. So look, do you see in your notes?
Yeah.
I could flip up to the top. It's going to take too long. All right. Cosine squared x plus sine squared x is equal to what? 1. So instead of writing cosine squared x plus sine squared x, what do we write? 1 over sine squared of x. Now, in a box, you should see something. Now, it won't say sine squared of x, but it will say sine of x. So that's what? What's 1 over the sine of x? Oh, give me a word. Don't give me CSC. Cosecant. It's the cosecant of x. So, if 1 over the sine of x is the cosecant of x, what do you think 1 over the sine squared of x is going to be? It's going to be the cosecant squared of x. Now, what were we trying to do in the first place? I got to flip up a little. I got to go up a little bit. Look.
It was cosecant. Oh, we got it.
That's right. So we got it. All right, that's what we were trying to do. We were trying to take this side right here and make it look like this side. Look what we did. We did it, didn't we? All right, so we made all this without moving anything over from the left side to the right side or anything like that. We actually got the cosecant squared of x. Let's go through it quickly again. Watch. I got cotangent of x. So I'm thinking, well, cotangent's the reciprocal of the tangent, but let's break that down even further. Let's break it down into sine and cosine. So what is the cotangent? It's the cosine over the sine. So what's the cotangent squared? It's the cosine squared over the sine squared. Okay? That was our first step. And then you just put the plus 1. Then you look at it, it's like, what do I do? Well, I could add those two things together. Well, this is a fraction, isn't it? So how do I add fractions? Find a common denominator. So what's my common denominator? Sine squared x. Put 1 here, put 1 here. Right? So here's the first part of it. And what do I do with this? I multiply that by sine squared x. I multiply the top by sine squared x. And that's what I get right there. I'm like, okay, now I got a common denominators. Let's put everything over one denominator. So I put both of those things over the one denominator. So I got cosine squared x plus sine squared x over sine squared x. Then I look at it like, is there anything that I recognize from any of that stuff that I'd learned? Oh yeah, I got one of those boxes, right, that has cosine plus sine, or sorry, cosine squared plus sine squared. And what was that equal to? It was equal to a 1. So I replaced that right there with a 1, right? And that's over sine squared. Like, okay, I think I remember I do have a 1 over sine, I have a 1 over sine, right, of x. What is that? It's the cosecant of x. So what's 1 over the sine squared of x? It's the cosecant squared of x, which is the same exact thing that we were trying to get it to be. All right? So that is how you do these proofs. Is that what you were having trouble with on the homework last night? Okay, so there you go. So you're basically just doing that homework, right? Did I add more to it? Can't remember. I think there was an A and a B, wasn't there? Let me flip. Yeah. So the first one was 1 to 16. All right. Did you have those to do, though, on 1 to 16? Yeah. You did have to do some of those? All right. Sorry, I thought I picked numbers that you didn't have to do. And then, so tonight is 20 to 31. 20 to 31. I think this, guess what this is? Your last homework assignment. That's right. All right, so this is what, 12:5? So it's section 12:5. There it is, right there. That's your last homework of the year. Just hang on to both of them. Since you had some of these problems on the first one, try to fix these, okay? And then do these. Your last homework of the year for geometry.